So we are doing the electron configuration. And our step-by-step, I'll say it verbally. The first thing you do is you write the element down. The second thing you do is you write the atomic number down. And that tells you how many electrons you need to place. And the electron configuration is exactly the same as arrow notation, except I don't have to draw the lines and the arrows. So no lines, no arrows. But you're still following this pattern, and you still start with one S. But now you need to know that S can only go to 2. So you would write one S and then 2. Does that make sense? So now I have 49 electrons to place. Are you with me? Yeah? Okay, then I go to 2s. 2s2. So I talked to you last Friday that if you are ending here, what is the last letter you're going to write? An S, remember? If you're ending in this area, you're going to write an S. If you're ending in this area, what's the last thing you're going to write? The last letter. A D. If you're ending in this area, the last letter you're going to write is a P. P. And then you can count because there's 6 P's. 1P, 2P, 3P, 4P, 5P, 6P. So what is the last thing I'm going to write? I'm going to write P what? If we're going to antimony. 1, 2. So the last thing I'm going to write is key 3. Okay? You can read the periodic table and I'll tell you that. I don't know what all goes in the middle. That's what this is for. Okay? These, you're going to end, the last thing you'll write is a what? F. Okay? So now I've placed 4 electrons. I have a ways to go. So I'm just going to follow my pattern. 2P, 3S, 3P. And notice antimony is in what period? So I'm going to start paying attention when I get to period. What period is this? 1, 2, 3, 4, 5. When I write 5S, I'm going to start paying attention. Otherwise, I'm just going to fly through this and not really worry about what it means. Okay, I just wrote 5S. Now I need to start paying attention. So I have 2. This is the outside energy level. So all of this is the inside. And now I'm to the outside. So how did I know what makes the inside and what makes the outside? Can you tell me? How did I know that? Are you going to talk to me today? Remember we have energy levels. Do you remember? And each one has a picture. Right? The outside energy level is the last energy level. So our last energy level starts with an S. So it's 5S because it's in the 5th period. That's how I know I'm on the outside. Everything else is the inside. Okay? So now I'm going to go from 5S to 4D. Fill up the D. Then I'm on 5P. And then what am I going to write? P3, not 5. Then to check yourself, I'm going to add up all these numbers, and they should equal 51, and they do. Does that make sense? Okay. Now, I would like you on your whiteboard to do the electron configuration for sulfur, neon, and beryllium. And when you do the electron configuration, I want you to circle the inside electrons in one big circle, like this. And I want you to put a square around the outside electrons. This is important. Can you do that? So go ahead and do that and hold it up when you get that done. And do one at a time, or unless, did you fit them all on your board, Peyton?
Yeah, I got them all.
Okay, now all you got to do is your circles and your squares. So you got to look at your periodic table and look and see what period sulfur is in. And you want to do the last period. So you need to look at the periodic table. Don't be afraid to talk to your people. I would like you to do sulfur, neon, and beryllium. Remember we were doing the sheet that we had? Do you remember that? Oh, we were on the second sheet, weren't we? I don't remember the problems on that. You'll have to help me. I think we did borium. What was the one after borium? Uranium, curium, strontium, tellurium, phosphorus, and carbon. So I erased what I said. I had the wrong sheet out. As a matter of fact, I gave all my sheets away. So I don't have it anymore. So please do uranium right now. I'm sorry. Okay, did you get it done? Can I see it? Did you mark down the inside and the outside? Okay, so uranium is in what period? 7. So you're going to find 7s, right? And everything after 7s is the outside, and everything before 7s is the inside.
So if there was a 7P on there, it wouldn't matter, it'd still be 7S.
No, you start at S and go through higher.
Ready? Do you want to show it to me so we can move on? So look over here. Do you see how your radium, look up here. Do you see how your radium goes into the spot right here? See that? The start of that energy level is X, or 7. So put your finger on 7S. Put your finger on 7S. That is the beginning of the outside. So that should be in the box. And everything after it should be in the circle. Does that make sense to you? That's better. Okay. Now erase it. And what's next on it? What? CE. Do CE. Okay, hold them up when you're done. Great job, Peyton. Go on to the next one. If you have questions, good job. Go on to the next one. Make sure you put your boxes in your circles. If you have questions, I can come and help you. Nice work, Rachel. Good job. Go on to the next one. If you have questions, advocate for yourself and I can help you. I'll be right there. Nice work. No, not yet. Getting the hang of it? Getting the hang of it? Okay, so if you remember I said when we were talking, this is the beginning of the row.
Oh.
So that is part of that. Yeah. Good, good. Does it make sense to you? Sorry, I forgot to take a little. Nice work. Yes, I'll be right there. Let me pour this. What row is Chauncey in? All three of them. Yep. So where's the outside? Five. Yep. Yep. So why is that confusing to you? Can you tell me? So all you do is ask yourself, what row, what period is the element in? And you would say 5. So then you look for 5x. And there it is. You can box it on it because that's all it is. Counting is 5x.
Okay.
Okay? And then everybody else is good. 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 Nice. Nice work, guys. What? Where's your marker? And that's hurting you pretty bad. Because not only did you miss school, but you're leaving everything behind. Your zigzag timer should be last week. It should be either in the 6th or the 5th. They're both, they're multiple ones. You have your zigzag timer right there. Oh, it's probably right there in your writer. Okay. It's in the dated folder that we did it. So all you have to do is go to the folder and click on it. Okay. So, I'm going to teach you something else now. Okay? So if you could stop. I'm going to teach you another thing now. So this is electron configuration, and with our electron configuration, I was doing the inside and I was doing the outside. So now I'm going to teach you noble gas configuration. Okay? So with the noble gas configuration, I'm going to take all of my inside. I'm going to take all of my inside electrons and put them in brackets. So I'm going to put a bracket here, and I'm going to look up and see what element is this, the electron configuration for. So can you tell me what element this is the electron configuration for? You would sum them up. 2, 2, 6, 2, 6, 2, 10, 6. What is that? If you add up those electrons, what is it? Did somebody say it, I thought? 2, 4, 10, 12, 18, 20, 30, 36. What element is 36 on the periodic table? KR. So we're going to put KR in the parentheses and put 36 there. And then I'm just going to write the leftovers. The ones on the outside. Oops. Sorry, I need to put a P there. Does that make sense? So do you understand why I was trying to get you to find the inside and the outside? Because you write the outside down for the noble gas configuration. Okay? Now I would like you to do the noble gas configurations for these problems for tomorrow. Okay? That's your homework. Now I'm going to transition back to our lab. Can you turn back to your lab? Lab 2. It's been a while. It's been 2 weeks since we looked at it. So open up your binders. Put these papers in your binder. Make sure you note that you have to do noble gas configurations. So you're using the noble gases. These are the noble gases right here, if you're wondering. So you're always going to have one of these elements in a bracket. And you're trying, not crying. So if you don't understand it, you're still trying to do it. Okay? So don't come tomorrow with your homework not done saying, I didn't understand how to do it. You need to try. Because all of you for sure found the inside and the outside electrons. And all of you for sure know how to do electron configuration. Okay? Okay, now, can you go back to your investigation, please? Go back in your binder. Lab 2, you should have a tab on it. Look through Lab 2. Read through Lab 2 right now, please. Do a quick read. Lab 2 had a lot of graphs. So start on page 3. And read page 3 quick. You do. You have the lab. We just want to read the words. Whether you have anything written or not, we'd like you to read the words. So this is going back before Christmas. So read those things. Right here, page 3. Start reading. Try to read through it all. Just a quick skim. Just a quick skim. Try to figure out what you were doing. Making sure you have all the questions answered. If you don't, then you're doing that as well as homework tonight. Because I'm going to be checking off this lesson tomorrow. Okay? So it shouldn't take you too long to skim it quick. You have some graphs to look at. Thinking about what the graphs mean. Okay, so you should have had some time to I have some time. Okay, let's make a list. Right at the end of your investigation, you should have some like open space at the end of your investigation. Do ya? Place where you can write. Let's make a list of what we've learned and connect it to what you just read. Do you have like a note page you could write on at the end of your investigation? Because now we're going to bring it all together. So bringing this all together. Now we're going back to the big picture. What did you do in your lab? What did you do in your lab? We're bringing this all together. What did you do in your lab? Can you talk to me? You took out electrons. And when you took out electrons, what did you measure? Okay, good. Thank you, Paige. Take the amount of energy to take an electron. Did we discover anything? Did we discover a pattern? Just by looking at the graphs, what pattern did you discover? What pattern did you discover? Just look at the graphs quick if you don't see it. So the more electrons you take, the what? More electrons taken, more energy needed. Okay, what else? What else? How can we connect this to what we're doing? Why do we go down the path of the electron configuration? What made us do that? Why did we start? We started it for a reason. What did you want to know? What did you ask me specifically? And I said, okay, I'll teach you. You wanted to know where the electrons were.
Oh, so we did that so that we know, like, whether it's like S, P, or D, and how that is significant amount of energy.
Yes. Do you see what he's saying? So you asked me, how do we know where these electrons are? And I said, okay, I'll teach you. So we learned where the electrons are in the energy levels of each atom or element. And now what I'm asking you to do, and what Andy's already started to do, is I'm asking you to take what you learned with electron configurations, just looking at the outside electrons, just the outside. Why do we not want to worry about the inside? Because they're what? Do they have all their electrons? Yeah, they're full. We'll only worry about the outside because they're not full. And that's where the chemistry takes place. So just looking at the outside electrons, connect the outside electrons where they're at to energy. That's what we need to do. That's what I want you to do.
So when we have like the blanks and we don't fill in all the arrows, that's where the chemistry is.
Yes, and we need to figure out what's going to happen. Right now we have a graph, a chart that tells us, hey, this electron right here in the S energy level for magnesium, you could look it up. Is it going to be taken away easily or not? And let's say, oh, I don't know what the ionization energy is for magnesium. Where did I show you to find it? Where do you go to find it? Do you remember where I taught you? On this periodic table. A special periodic table. And it tells you go to electrons. I go to the electron tab. And so let's say we do antimony. Here is antimony. Here's the electron configuration. There's the gas configuration. You should understand that now. Here are the energy levels. And you can spin it, and you look inside there. There's a lot of different energy levels. Right? You can see them all in there. They all have different colors. They alternate. And antimony will have 5. Now, I can ionization energy for this. Ionization energy for that, if I go to properties, whichever one I want, because there's a lot. So this is taking 1 electron from antimony. It takes 834 kilojoules. Kilojoules per mole. Kilojoules is a label for energy. It means 1,000 joules. Now, if I compare that to rubidium, rubidium's first ionization energy is 403. Helium, first ionization energy is 2,300. So what does that tell you about helium? Does it want to give away its outside electron? No.
So the less electrons, the more.
Not necessarily.
It's just helium.
You have to think about where the electrons are and think about the attractive forces. Helium's pretty small, and the electrons are negative and the protons are positive, so the distance between them is what? Very small. So that means that the force of attraction is going to be great. Francium, only 380. That's big. The distance from the outside electron to the nucleus is big. So there, the force of attraction is a what? Very big. It's not very big. It's very small. Okay? If the distance is great, the attraction is weak. Right? So, now what I want you to do, and we are closing in on not very much time here. If you could, go to the activity summary board and add some things to it. To it. So our question that we're answering is at the top of your page. I'll put that in there. What is some evidence? So those are the numbers from our chart. And then what are some things that we learned, like from our notes, from our electron configuration? So can you please add, you have 2 things. You need to do your noble gas configurations, and you need to add some things to the activity summaries board for tonight, okay? This should take you 10 minutes. Because you already have the electron configurations done, the noble gas configuration should be very easy. So you have 2 things for homework. Activity summaries board. And remember, your semester exam is your retest, so you're going to have 2 things for your semester exam. You're going to have a model that you'll start drawing tomorrow, and you're going to have your makeup tests. Okay? And in order to do the makeup test, you need to make sure that you have all your homework done. So I'll talk more about that tomorrow.
So ingenious for using the Santa Notebook page.
No, you're not slick, Andy. You're about 3 years behind.
I don't think you're 3 years behind.
Well, I lost my assignment notebook for this year, so I'm using one from 3 years ago. So when I went to write in I have chemistry homework, it said that the 10th is a Thursday, and I was really confused.
I did not get this all written down.
Okay, but I made a video.
You made a video?